Module 16, Validating Data. In Module 16, we'll be using totals as visual checks, using formula for automatic checks, using the rangefinder, auditing a worksheet, using error checking, watching and evaluating formula, some exercises and their solutions, and a final summary. So why validate data? Well, with large or bulky workbooks, it helps to have various methods of error checking. Reliably validating data helps prevent the rise of any cumulative errors, and using totals in validation can make it easy to find summarized data. So let's begin. Before we get started, it might be helpful to use the Developer tab for some further functions within this module. As you can see, on our ribbon we don't have a Developer tab. To create the Developer tab, go to the drop-down bar here for the Customize Quick Access toolbar options. Go to More Commands and go to Customize Ribbon. As you'll notice, the Developer tab is unchecked. Check the Developer tab and click OK. And the Developer tab appears here at the top in the ribbon. Clicking on the Developer tab opens up further options with macros, add-ins, and inserting form control. For example, the Insert tab here contains our form controls. Form controls help us when it comes to data validation and also speeds up data entry. The one we'll be using for our module is the checkbox. To use the checkbox, select the cell you wish the checkbox to be inserted into. Click on the Insert button and click on Checkbox. Our cursor changes to a Draw Checkbox cursor. Clicking inside the cell will create the checkbox. We may need to move this into a better position. We can also alter the text next to the checkbox or remove it altogether. And we can also resize the checkbox as well. Once we're happy with its position, click away. The checkbox works by checking or unchecking what's within the box. But if we click on the cell it's contained in, we can see there's nothing inside the formula bar. However, we need to add a value to our checkbox, or at least know where our value is stored. So if we right-click on our checkbox and go to Format Control, the Format Control window opens, and we can add a cell link. Generally, we can just add this cell where the checkbox is contained as our cell link. So, the selector, click on the cell, and press Return. Once we're happy, press OK. Now if we check our checkbox, the value True appears next to it. If we uncheck, it changes to False. We may need to resize our cells to see this more clearly. So let's continue with the first part of the module. We have another fictional spreadsheet here for Springvale Limited, where they have a charity event on with recipient name, the company they work for, whether or not a ticket has been sent to them, a validating column, which we'll come back to, have they replied back, the RSVP, their email, and the expected donation if they turn up. To the right here we have two different validation columns. This is a ticket sent validation and RSVP validation. Normally these columns will be hidden or the true or false value stored within these two respective columns here. But just to show you how validation works, I've kept them to the side so we can see any changes take place. We also have the amount of tickets to be sent, the RSVPs received, and a confirmed count of how many will turn up, and a donation total should they turn up. So to use totals as a visual check, the easiest method is of course to use the AutoSum feature. We can select our data range, click AutoSum, and the values are automatically calculated here at the bottom. Remember, this is always a function. In this case, the sum function. So equals sum G4 to G9 means that anything within the G4 to G9 range is calculated here in the bottom. Also, if we change any value, it will automatically update. This is a handy feature, but it doesn't help us here. Calculating the donations here is helpful only in regards to the amount of donations we can potentially receive. Unfortunately, due to the way the spreadsheet works out, all the donations are conditional. In other words, if one of our recipients turns up, then the company will receive the donation. To help validate these totals, we have 4 different totals set up. We have our AutoSum for our maximum possible donations. We have the donation total that's based on how many people turn up, a confirmed count of how many people may turn up, the amount of tickets to be sent, and the RSVPs received. This is where our checkboxes come into play. If we send a ticket to J. Smith, with the check in the box, the message next to it changes and tells us that a ticket has been sent. If J. Smith then replies, the tickets to be sent goes down by 1, the RSVPs go up by 1, the confirmed count goes up by 1, and the donation total updates. If we send a ticket to T. Burgess, but he doesn't reply, no other changes will take place. If we send a ticket to L. Tucker, and they reply, we have 3 tickets left to be sent, 2 RSVPs received, a confirmed count of 2 people, and the donation total has gone up by J. Smith's 1,000 contribution and L. Tucker's 750 contribution. So let's have a look at how this works. So let's look at the ticket sent area first. Checking or unchecking the box changes the validation here. True or false. We can also see that when we check or uncheck the box, the message to the right changes. Our tickets to be sent total updates as well. The ticket sent area is what's called an if statement. If I4 is equal to true, then display ticket sent. If it's anything else, display send ticket. As is currently true, the ticket sent statement is appearing. If we uncheck it, it changes to send ticket. But we can use if statements in other ways too. If we click on an empty cell, I'll paste in an if statement I've already typed out. Big spender. But this cell has an if statement. If G4, here's G4, is greater than 990, then display big spender. If it's anything else, display miser. As G4 is 1,000, it displays big spender. If we change G4 to be less than 1,000, it changes to miser. And as you can see, our AutoSum updated, as well as our donation total. So that's the if statements, and we'll be coming to that in later modules. The other visual check that's in our spreadsheet is the tickets to be sent. This is what's called a COUNTIF function. COUNTIF D4 to D9 contains send ticket. So in this range here, if D4 to D9 contains send ticket, count how many times send ticket appears and place the count in this cell. There are 4 send tickets in our column, and the 4 is updated here. If we add another ticket, it decrements down to 3, as there's only 3 instances of send ticket in these 3 cells. So the COUNTIF works like the if statement, but in this case it adds a function to the if statement. Count if this cell range contains this value. And we've done the same thing in the RSVPs received. Count if J4 to J9 is equal to true. J4 to J9 has 2 true statements so it's incremented to 2. And we've applied the same thing with the confirm count. Exactly the same function. The last visual check is in the donation total. This uses a separate function called the SUMIF function. SUMIF J9 contains true, then increment donation. In other words, any instance of the word true within this range will add the donation from it to this cell. So we have 2 trues of 1,750, and this has been added together within this total. Using totals as visual checks is a great way of summarizing data. We can see at a glance exactly how many tickets need to be sent, how many people are confirmed to arrive, and what the expected donation may be. We can also use the subtotal function. If you need more information on the subtotal function, please revisit Module 12. So we've seen how totals can give us visual checks, but what about making some formulas that can do these checks for us automatically? I've inserted 2 formulas into the spreadsheet. There's one here and one here. What these formulas are designed to do is, if an unexpected value is returned in these cells, then an error will appear here, and we can see straight away what that will be. For example, if we look at this formula, I have an if-or statement here. So if G10 is greater than 6,500, or if G10 is less than 0, then return error. Anything else, return OK. So for example, this is the expected value from our donations. If we go over this value, the cell returns an error, and it turns red. It turns red because I use conditional formatting. In this case, anything that contains the word error will give a light red fill with a dark red text. And the same thing here. If B15 is not equal to B13, return an error. Otherwise, click OK. So while we have our spreadsheet set up to automatically reply and add from the RSVPs and the donation total, if someone accidentally types in a new value here, it returns an error. And once the values are reset, the 2 cell values also reset. So let's add a formula to the spreadsheet. In the cell next to the donation total, we're going to add another if statement. Remember, all functions and formulas start with an equal sign. Equals if. Then we open the argument, and then we set up the logical test. In this case, anything over 6,500. So if E15 is greater than 6,500, then return an error. Anything else is OK. And then we close the argument. So we have our if statement, our cell range, our logical operator, which is the greater than sign, a value, 6,500, and then the statement to be returned if false, and the statement to be returned if it's OK. Once we're happy with that, we click OK. As the value is under 6,500, it remains as OK. If we click it and change the value, we get an error. And we can also add some conditional formatting. So we can use the highlight cell rules for text that contains error. And then click OK. So using if statements, and statements, and or statements can help us maintain precision within a spreadsheet. If you need further information on using functions and formulas, please refer to Module 9. We've actually seen the rangefinder at work when using Excel spreadsheets, particularly when we come to use functions and formulas. If we click on a cell that we know contains a formula, and then double-click it, the blue box is the rangefinder for this particular formula, in this case E15. If we click on another cell that we know contains a formula and double-click that, here again is our blue box, which is our rangefinder. To click off this or to click away, just press Enter or press Escape. If we look at this formula and double-click, we can see two rangefinders. The one in blue, B15, is highlighted with a blue rangefinder box, and the one in red, B13, is highlighted with this red or pink rangefinder box. Where we have more complicated formula in E15, we have an array rangefinder here, J4 to J9, which is in blue, and the donation range, which is in pink. If we need to move our rangefinder or resize it, moving the cursor to the edge of the rangefinder box gives us our cardinal point compass cursor, and we can literally move the entire box and its range up, down, left or right, or wherever we need to put it. If we only want part of our range, we use the toggles on the corners. This allows us to make our ranges smaller or larger, or incorporate larger ranges. What's handy about this is if we have a formula that can be used elsewhere, we can copy our formula, paste it elsewhere, and then move the rangefinders to the correct positions that we need. Our spreadsheet is quite simple, but what if we had a spreadsheet that had many values, many formulas and functions, or was very large? Even with our current spreadsheet, we have many different formulas and functions, but they can't be seen, and sometimes it's helpful to know how they work. This is where the auditing function can help. To use the auditing functions, go to the Formulas tab in the ribbon, and they're here. There are 6 options here, and we'll return to the error checking in a minute or two. Let's look at the options on the left: trace precedence, trace dependence, and remove arrow. How trace precedence works is if we have a formula in a cell, as we do here in D4, we can see what cells this function relies on, and also see where this function gets its values. So for example, if we need to see where this cell gets its values, we click on trace precedence, and an arrow appears that tells us that cell I4 provides its values to the function stored in cell D4. If we need to see where this value gets sent, if it gets sent, we click on trace dependence. So what we're seeing is what cell relies on this one. So if we click trace dependence, we can see that the value here goes towards the function stored in cell B12. If we look at cell B12 and look at the function stored within it, we can see we have a countif function for an array D4 to D9. So if we click on its precedence, we can see that the function in B12 relies on all the values in this array. All the values in this array also rely on all the values stored in the array I4 to I9. This might seem complicated, but it's just helpful to think of it as the value here gets pushed into the function there, and the value performed by this function gets pushed into the function here. And we can do this with all the functions. We can see where they rely on and where they go. Sometimes this is the end of the line, so there's no trace dependence found for this formula. To help us out when the arrows get quite complicated, we can remove arrows. We can either remove all the arrows or just remove the preceding arrows or the dependent arrows. Or remove them altogether. Another auditing function that can help is the Show Formulas button. If we click this, instead of seeing the values returned by the formulas, we see the formulas. And clicking on a formula will also reveal the rangefinders as well. When we create a formula, particularly if it's a complicated one, we can click on our formula and also use the Evaluate Formula button. A window opens and allows us to evaluate each area of the formula to see if there's any errors or to see if any changes need to be made. Clicking on Evaluate will run through the formula and then reveal the answer. Clicking on the Show Formulas button again will hide the formulas and return the values. If we have a problem with any formulas or functions in Excel, Excel will give us a range of different messages. In this case, in cell F12, we have an incorrect value in our formula. When we highlight the cell, we get this exclamation box here on the left-hand side. If we click on this, it gives us a range of options to deal with the problem. The best way to deal with the problem is to use the Formulas tab and the Error Checking button here. There are two options. We can trace the error or go through an entire spreadsheet error check. If we trace the error, we get an arrow to tell us where the problems are coming from. In this case, the problem's coming from either G10 or the range G4 to G9. We can also remove these arrows. The other method is to use error checking, which, much like spell check in Word, will go through the entire spreadsheet looking for problems. The problem it's found is in the same cell, cell F12, and it's telling us that there's an error in the value. So there's a value within our formula that is incorrect for the formula. We can either click on Help on this error to open up the Excel Help window, show the calculation steps, which we'll do in just a moment. We could ignore the error or edit in the formula bar up here. If we go to Show Calculation Steps and Evaluate, the problem is here. This value currently within our formula is incorrect. We can click on Evaluate and it will evaluate the next part of the formula. Step into the formula to make sure the values are correct. Once we're happy, we can step out and continue evaluating and see that the problem lies within this section here. So if we close this, go to Edit in Formula Bar, we go back up to our formula bar and look at our formula again, we can see that the if/or statement requires G4 to G9 to be greater than 6,500. This range should really be G10. So we can select our rangefinder, move it and resize it back to the correct position. Once we're happy, we can click OK and we can see our formula is now working correctly. It's exactly the same as the formula held in F10. We can then resume the rest of the error checking to make sure there's no other mistakes within our spreadsheet And once the error check is complete, we click OK. We've seen how the auditing features within the Formulas tab work, but we haven't yet looked at the watch window. The watch window is a handy feature that allows us to keep track of a cell or a group of cells, their values, or how their functions are working within it. To use the watch window, click on the cell you'd like to keep an eye on, then click on Watch Window. The window opens. If we click on Add Watch, it asks us which cell or cells we'd like to keep an eye on. Click Add, and the new watch appears underneath. It's held in the book Springvale in Sheet 1. If there's a named range, it would appear here, the cell we're currently tracking, the current value held within the cell, and any formulas that may be attached to it. We can also add another watch. I've changed these two formulas. So if we click on this one and go to Add Watch, again, we confirm the cell we're trying to keep an eye on. We can see again it's in Springvale, Sheet 1, cell F10, the current value is OK, and the function that's held within. How Watch Window works. If we have a very, very large spreadsheet, or keep needing to navigate between different sheets and different workbooks, the Watch Window allows us to keep track of what's happening within one cell or a group of cells without having to navigate back and forward between them. If I now move down so that my functions and my values are out of sight and start adding values here, we can see the value within cell G10 changes just by observing what happens within the watch window. And if I keep adding values, the value in cell G10 changes, and if we notice in cell F10 we now have an error. The reason for this is because I changed this formula so that if G10 went over 11,000 we got the error return. So we can see just how useful the watch window can be when it comes to keeping precision within a spreadsheet. When we're finished with our watches, click anywhere on the watch and click on Delete Watch to remove it once more. And then we can close the watch window. For the exercises, use the Springvale exercises file held within the Module 16 exercises folder. As you can see, I've changed the file slightly to make using the functions a little easier. For the first exercise, create an AutoSum function within cell E11 for the expected donation total, and create another AutoSum inside cell G11 for the donation total. When using the AutoSum exercises, use the range finder to adjust the range to get the correct answer. Okay, so we should know by now how to create an AutoSum. Click the cell we wish our AutoSum to be in, click AutoSum up in the top right of the Home tab in the ribbon, and then adjust the range finders. To get the correct total. For the next exercise, add two formulas to the expected donation error check and the donation total error check to make sure that neither the totals held in E11 and G11 go over their range. So the two formulas to check for errors within these two ranges are if statements. Click inside the cell and remember all functions start with an equal sign, then the function name, followed by the start of the argument. Then we set our logical test, so we don't want E11 to go over 5,250. Then we put in our two values to be returned if true or false. Then we close our argument and click OK. So as our range does not go over 5,250, we get the OK returned within the cell. We could do the same thing with the next cell, just by copying this formula, pasting it, and changing the values. So instead of E11, we now have G11, but we must change the total. In this case, we need to go to 6,825. And then press return. We can do a quick check of our values. And as this one incorrect entry has pushed this one outside the range, in turn pushes this one outside the range, we get an error message in both. For the next exercise, use the auditing functions to find out the precedence and dependence of cells E4, F4, G4, the expected total donation, the donation total, the error check, and the donation total error check. Okay, so to use the auditing functions, we go to the Formula tab in the ribbon, click on our cell, and click on Trace Precedence. There are none for this because this is the start point. So we trace the dependence. We then go to cell F4, Precedence, Dependence, G4, Precedence, Dependence. The reason for that beep, by the way, is because the precedent has already been traced. Precedence again, and the dependence. Precedence and dependence, and the last two. That's the end of the line, and so is this one. So we can see, just by following the arrows, exactly where each cell relies on its next value for its function to perform. When we're done, we just click on Remove Arrows. For the last exercise, use the auditing functions to perform an error check on the entire spreadsheet, and then finally create a window watch for cells B11 and B13. Once the watch is set up, change the value in E9 to 751. Then delete the two watches and close the window. Okay, so to perform our error check, we go to the Formulas tab, go to Error Checking, and the error check is complete for the entire sheet, as there's no mistakes. Lastly, we set up a window watch for cells B11 and B13. Then we change the value in cell E9 to 751. We can see that our window watches work correctly. We then delete our two watches and then close the window. So Module 16 in summary. Excel has a great array of error checking functions, but it's clear that establishing our own methods of correction can really save time. There's a wide variety of methods of ensuring precision when adding data to a spreadsheet. and using the auditing functions gives a more visual method of tracking functions through a workbook. Thanks very much, and we'll see you in the next module.